I think so. You have covered pretty much everything, Shaisa. And Robert has been professionally, he's been a very sound professional, respected very much everywhere. I have seen him in the meetings. He's a very avid speaker, representing himself in big conferences like ENACOM, one of the biggest conferences in energy sector, addressing thousands of people. He has got extremely good management style, and he blends very well. He has got diversified industry-wise experience, mainly in energy sector with oil and gas, chemicals, and then more into banking, and also with technology firms like WellLogics and etc. And beside this, he's a very good human being. He's a good boss. He's very calm, and he's extremely knowledgeable. He usually stays quiet, but when he starts talking, then he is like a well of knowledge.
Oh,
So yeah,
wonderful.
and beside that, he's also actually helping in causes like he is pretty active because of his international friends on America's side, which is Ecuador, Panama, Costa Rica, Brazil, these types of countries. And he has been very active in the incubator accelerator.
Oh, great.
And he's been a panelist for startups. So I
Wow.
think so. Yeah, yes, and he has been a panelist, and I think so. We are actually working on something and shortlisting, which is going to be next month as well in Ecuador.
So have you been to Pakistan, Robert, or this part of the world?
I have not. My father's been there a few times
Wow.
in the past, but I have not.
So great. So ladies and gentlemen, we'll be proceeding further. Today's session is, it will help us learn and to develop insights and understanding of business technology trends, especially the COVID thing and the oil prices coming down. And we'll hopefully we'll get knowledge about knowledge management, the tools of IoT, RP, and AI. Robert will be having many MBA students as well. So I will also appreciate if you can give them tips as well, how to prepare
Yes.
for the next future. Because the corporate, there's an American book by Professor Miles. It talks about the vanishing American corporation. And it says that we need to develop an entrepreneurial mindset. So I hope you can do that.
Well, hopefully I'll do okay with this. And if we have any interruptions, I'm usually pretty good at rolling with the punches, as they say. So ready for that. So anyway, thanks for all the great introductions. It was great to hear about IBA. It was great to hear about everybody's background. I've listened to a few of the speakers along the way during the series. They've all been fantastic. So I hope I can do as well and do good by everyone with this. So as I kind of went into the topic, a lot of ideas got thrown my way about technology pieces. There were some questions about what is IoT, what is robotic process automation, what is AI, what is cloud, different trends. So I kind of moved it to more of a general trends and not try to go too, especially in a business setting. And in my background, I've been kind of a business technologist myself. So it's how do you apply technology to solve business problems, not really just technology for the sake of technology. I let the scientists invent those tools, and then I try to figure out how do we as business people best apply them to solve problems. So I decided to back it off to a little bit of business technology trends, and going to focus a little bit initially on three areas, being most popular, and then talk about how some of those other trends overlay with them. I won't try to go too deep in any one topic so as not to make it too overwhelming or too technical. But if anybody would like to follow up later, contact me. I'd be happy to deep dive into any of the other topics. So technology, always an exciting topic. Let's see, we have a good turnout. People like talking about it. And why do people like technology? Well, it opens up, it's exciting, it's new, it's modern, and it opens up the ability to gain a lot of insights. How do we go into new markets? How do we compete more effectively? How do we compete with our local competitors? How do we offer new products and compete with larger firms? Everybody always knows all the big tech firms, the Amazons, the Teslas, the Apples, because they release the new products. They start new innovation. They come up with ways to tools that we can use to manage our business. Think about what you do. I carry an iPhone, carry an Android. If you think about the things that you can do with your phone, if you go back to those who remember in the 90s, people were just starting to carry mobile phones. You didn't usually collaborate with your coworkers too much after hours unless you were in an extremely critical infrastructure type job. Doing international conference calls or international communications in those times was actually a pretty big deal. And those tech companies have brought us those capabilities to do things like Zoom meetings and to time shift, as they say, working with people in different time zones and around the world. And there continues to be just really explosive amount of growth in the amount and variety of technologies that are coming out there that we can leverage. So let's talk about a few of those. Well, real quick, one of the things I do like to talk about is I get kind of excited. I went through, if any people remember the dot-com boom, as it were, when the Googles of the world were starting, when the Amazons of the world were starting. That was a pretty exciting time. And we're kind of in a wave of that digital transformation right now. First couple of waves was people going from paper to putting things online, getting things in computers, computerizing records, managing things more effectively, having access to go back and look at data without having to send somebody back to a file room where things were stored offline. Then we went into, people communicating online, putting together the internet, and then the World Wide Web on top of that. And then e-business becoming a way to do trade that was challenging the traditional ways of doing business, and then kind of became the de facto way of doing business. Now we don't, you don't think of it too often. I remember colleges debating 10, 15, 20 years ago, should there be e-business degrees? Well, now just kind of business degrees, or e-business is an aspect of a business degree now, right? That wave has just become the standard way of doing business, and things that we thought were cutting edge at those time are just standard. Now, the things that are happening with some of the topics we're going to talk about today, they build on those foundations we laid. There's more data to analyze. So, it was one thing when, wow, it was neat that you could go, if you knew a record and a customer number, you could go look up a customer without having to go to the file room. But now there's so much data that's been digitized. How do you actually find that data again? There's so many more people creating content. There's so much more data coming online. How do we deal with all that? And how do we leverage all that to run more effective businesses ourselves? So I'm going to look at a couple different technologies that people have thrown out some questions on, and we'll talk about how they're used. So they're going to be, you probably heard them by their names: IoT, sometimes a little O, sometimes with a big O, RPA, and AI. And what do those exactly mean? First, I'll define what those letters stand for, because some people, sometimes I even forget what they stand for because we throw the terms around so much. And then there have been some questions about cloud computing and open source platforms. And one of the neat things there is the availability of those kinds of trends to allow these technologies to be available to not just the largest companies, but to the entrepreneurial startups and to newer firms and newer entrants, and giving them the ability to compete in ways that you really couldn't do even 20 years ago with the initial online pushes that came over the last few decades. So IoT stands for the Internet of Things, connectivity of things to the network. So what are we talking about things being on the network? Well, you have, if you're in a factory, there's sensors. They're saying, a bolt of fabric has jammed up the assembly line. And rather than somebody seeing the assembly line start, we're seeing, we're getting a message maybe while we're at home that something is jammed, something's not working right. Or we get a message that everything's going great and we're running ahead of production schedule. It's smart grid. I did a lot of work talking about power generation. I did a lot of work with power companies, Con Edison, New York Smart Grid Project, British Columbia Hydroelectric in Canada, Oklahoma Gas and Electric in the US. And it was just fascinating that we were able to do things like talking to smart meters. If, your metering system that used to be, companies would do their billing and their planning, you'd have an electric meter on the side of your house not that long ago, and somebody from the power company would drive out, take a quick look at your power meter every 30 days or so, and if there was a dog in the yard or the gate was locked and they couldn't get to it, then they just guess what you used and catch up your bill 60 days later. And they make all their planning for new decisions based on a person going out and reading that meter and then taking it back in and typing that data in. Well, one of the things we found out in some of these projects is, we could read those meters every 6 seconds. We could actually send data over Wi-Fi. We could send data over the power lines, which is kind of interesting. You can actually send data over power lines, and we could actually monitor those. We could actually monitor power usage on a minute-by-minute basis. Actually, we read the meters every 6 seconds. So what did that allow us to do? Well, it brought in some interesting opportunities. One, we could bill people more effectively. Two, we could help our customers be incentivized to work better. So what does that mean? So some of our customers, we found out, were paying very large electric bills. One of the things was very small grocery stores. In some of the rural areas of America still, there's small grocery stores scattered all over the place. And when it would get hot in the summer and everybody would turn on their air conditioner, the power grid would start to get stressed. And we were realizing that we were going to have to build more. We were going to have to build more power plants in just to work with that demand. All right. So one of the things we learned with these rural grocery stores was that we were getting ready to build new power plants to meet the demand, because we'd run out of the ability to generate enough power, and we'd have rolling blackouts would occur where we'd lose power. And then we realized that these rural grocery stores, a lot of times, right at the hottest part of the day, were getting their deliveries and opening up all their freezers and restocking all their supplies. Well, through Internet of Things, we started managing the power demand of each of these freezers, and then we started giving our customers breaks on the cost of power if they would reload the freezers during the coolest times of the day as opposed to during the hottest times of the day. And the amazing thing was, it actually allowed us to put off the construction of a planned power plant by about 20 years from a planning perspective, just through something as simple as managing the amount of power that was used by hundreds of little grocery stores opening their freezers. Or in the case of Con Edison, New York, we found out we could do things like start up remote generators. Large facilities there would have generators, whether it was hospitals, universities, and we could actually start them up and run the generators and inject power into the power grid based on when we saw problems and they were ready to have brownouts on the power grid, where power would get low and computers would be damaged and TVs would shut down and air conditioners would go offline. That we could actually remotely start up the generators and put the power back into the power grid, and protect the power grid and make sure that there was plenty of power for those hospitals when the time came, like storms and things came by. But it's not just things of that size. It can also be things like Internet of Things also encompasses consumer products or things we use ourselves, like smart thermostats. If anybody's seen, Ecobee thermostats or Nest thermostats, you can put them in your house. And if you're traveling or if you have them in the baby's room, you worry about comfort. You can have the system go back and forth automatically between air conditioning and heat to keep everybody comfortable during the times as the heat and the temperatures go up and down. You can manage that, and you can actually do some of that optimizing to save power. One of the interesting trends is it used to be when people would put up large server rooms, you'd have a team of people that would manage computers that are very sensitive to heat and cold, that would try to manage the temperature and the humidity in these server rooms to make sure there was that the computers were not damaged. And you get large expensive components for managing that from Siemens and General Electric and companies like this. Well, a lot of smaller companies now, maybe a small bank that has 5 or 10 computers on site, realize you could put a $200 Nest thermostat, tie it into a inexpensive air conditioning system, and you could actually, using the Internet of Things, have kind of the same kind of ability to manage and monitor your computer room that used to be 10 or 20 years ago only a large corporation would have. Video doorbells are another example, various monitoring solutions. The neat thing with all of this is that before, if you think about it, you could only respond to problems by exception, as we say in the tech world. Dealing with issues by exception, meaning when that assembly line breaks down, that's when you have a problem. As opposed to, if you're monitoring those tools, you can start to see, my machines have been running hot. Why are my machines running hot all day long? What's going on? I can go in there and ask somebody to take a look at that ahead of time before the problem happens. And that's a kind of preventive maintenance that before was only done by the largest factories. And that was, when you're a small scale manufacturing operation, one of the problems that you run into is your larger competitors usually one of the advantages they have is they have more uptime. Their lines run for longer periods of time than yours do. Now, Internet of Things, very simple, very inexpensive monitoring, hundreds of dollars as opposed to hundreds of thousands of dollars it used to be. You can have that same type of capability. Now, one of the issues that you run into is that this generates much more data, and people need to manage that amount of data. And then the other is, how do you deal with this data, and how do you process the action? So I'll talk a little bit of that. That'll lead into some of our other topics, but I'll throw up a quick slide here, talk about some of these kind of capabilities and point to each one of these. And there's your Nest thermostat. Some of you may have seen those. They're very popular in the US and throughout Europe, and I think they're going all over the rest of the world as example. I personally have started seeing these pop up in small server rooms at the small mid-sized companies I have, and then also people starting to put them into, which I don't think they were originally intended for, refrigeration type rooms for monitoring temperatures in there, make sure food isn't spoiled in food storage or food preparation type areas. That center spike into the ground there, back in the day, large factory type farming operations, guys getting into like the Monsanto side of farming would go out and monitor their soil. So smaller farmers would have to go out and, maybe dig up their soil, kind of walk, see what the ground felt like, decide, is there warm spots, are there dry spots, are there wet spots? When should I plant? When should I fertilize? When should I water if I have access to irrigation? One of the areas that's gotten very neat and has gotten a lot of progress, that's a soil sensor. So that actually checks quality of the soil. It talks a little bit of what kind of minerals are in the soil. How dry is it? Is the soil too dry? Is the soil too wet? And helps, those are very inexpensive devices now. That's become a very big area that allows people to go out and decide when's the best time to actually to fertilize, to plant, to harvest, with really capabilities that were only accessible by the largest firms really not that long ago. The next three are ones I put these up here because I can speak to them because they're ones I was involved with. The two little black boxes there with silver sensors, those are explosive gas detectors. So those are used in factories. They're used by firefighters. They're used on ships and components like that. One of the things we realized is that the way people dealt with trying to avoid fires in areas, whether it's oil and gas or whether it's manufacturing, is that they thought they smelled gas, which was sometimes gas has an odor placed in it, natural gas, to warn you that there may be a gas leak. But there's lots of other benzenes and toluenes and xylenes and hydrogens and things like that that are used in manufacturing that can occur due to cargoes on ships or cargoes in warehouses that can be an explosive that people can't smell. So what would happen before is if you expected that there was a problem, but of course then you had to have reason to know there was a problem, like something was leaking, you would go out and you get a very expensive sensor, and somebody would go out and walk around and survey it and say, hey, do we have explosive gas available? These little devices speak over a long-range, low-power network. It's basically free, and then they're very inexpensive in terms of gas monitoring, and they could be deployed in anywhere from a refinery to a warehouse to a manufacturing facility. And instead of somebody going out and looking with these when there's a problem, they can sit and run off a small battery for years and actually just sample the air every few seconds. And if there's a problem, warn you ahead of time so you can clean that up before a problem happens. If you think about that, not that long ago, that would be something that you might see at a Shell chemical refinery, but you probably wouldn't see that in a small operation. But again, those are devices a few $100s using basically a free network that can monitor continuously. The one on the left, that's actually a well site for oil production. This actually was my truck at the time, parked in front of it. The small tan device at the bottom of those towers is injecting chemicals to manage the pressure in an oil and gas well. And this was actually, we were working with XTO, it's a division of Exxon. And one of the things that they were finding is that there's water goes into oil and gas wells. There's also water that comes out of oil and gas wells. The kind of wells they do in the U.S. now are very, very, very deep. And there's kind of ancient trapped water supply intermingled with the gas, not really mixed because it's oil and water, but intermingled. And they have to treat that water as they take it out of the ground and separate it out. But some of the chemicals that treat it actually negatively impact the chemicals that you use to treat pressure. So that small shipping container looking device down there, they were actually made from shipping containers, was a small entrepreneurial company I was working with that ended up getting quite a bit of contracts with Exxon in Canada, which is a large Canadian American company, EOG, which is a large US oil and gas company, to manage the injection of the chemicals that manage pressure. And the way that they were able to compete with their much, 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 much larger competitors, I'm talking this was a 50-person company, was because we were able to implement IoT-like capabilities. So if you see that little snapshot of a phone screen to the right of that, what we were doing there is we could actually monitor on a second-by-second basis the quality of the water that was coming out. And what we found out was that the people managing the water were overdosing the chemicals needed to clean up the water. So, and that was destroying the chemicals that were supposed to be managing the pressure. And Exxon was paying way too much money to everybody. But it was actually the smallest company that was out there working on that drilling pad that was able to solve that. If you think about that, the chemicals that you use to manage it, the processes you use to manage it, are the same processes you use to manage providing clean drinking water. There's a parameter in there called ORP, and people who are managing not just oil wells, but people who are managing drinking water systems constantly are going out there and having people dip and run chemicals to manage the ORP of water to see if it's safe to drink. And you can use the same technology, again, managed from a phone, to monitor those kind of parameters. Next to that is that's from the same customer. This is where we're actually another little system that we built that was allowing somebody to sit remotely and manage based on the parameters they were seeing on their phone the amount of chemicals that were injected. So we didn't use too much and we didn't use too little, and we did exactly what we needed to do to keep things running smoothly. And that was a pretty big success that we had with Exxon. So then now we have all this data flying in. Now people have to deal with it. So how do we deal with all this explosion of data and all the forms we need to fill out and all the things we need to do to take care of that? Well, if people have heard the term RPA being thrown around. That's what people call robotic process automation, which is kind of a misnomer. A lot of people think there's actual robots involved. There's not. What we're talking about is the automation of repetitive tasks. So maybe it's the filling out of forms. If you're in a call center, you're talking on the phone, you're taking in information from 3 or 4 different systems. You're logging in the customer you're talking to, then you're swiveling your chair to the left and looking them up in the billing system. Then you're swiveling your chair to the right, and you're looking them up in the payment system, and you're looking at what their account looks like. And in the U.S., we call that swivel chair automation. The way we tried to solve that in the last few decades was by tying those systems together very carefully in the back end with a very expensive SAP and Oracle provided system. Robotic process automation is a lot lower, less expensive entry point that allows people to go in and interface through the front end, whether it's filling out of forms, medical forms, banking forms. One of the neat examples I had with this is I was working with Allied Signal Honeywell back in the day, and they were having a problem they started automating all their systems, doing some IoT type projects and things like that, and they were generating a large amount of transactions that a very small accounting group in there had to go in and fill out forms to submit transactions into yet another system. So all month long, they would actually the employees only got to work at their core jobs for about a week out of the month. And then for the other 3 weeks, they were just typing in filling in forms to solve all the problems for all the incorrect transactions that had been put out there through the automated system, basically doing cleanup. So we did a little bit of AI, which we'll talk about next, and we tried to clean up the transactions. And then we said, well, gosh, how do we free up these employees work on things that are value added. And the way we did this is we wrote a robotic process automation tool that would go in, figure out what data needed to go, and let's see. Oh yeah, I think we're getting a few. I think we're getting a little bit of.
Yes. We have Elias Ali and we have Ikra Naz. If you can please mute your mic because there's a lot of noise otherwise. Elias Ali, you also please, if you can hear me. Can you please? Yes, thank you.
Okay, so what we did is we actually created a robotic process automation tool that would go in and fill out the forms for the people, so that freed up their time. And the fear that people had is we had a small outsourcing group from a small company that was filling in the forms for us, and they were terrified at first that, wow, we're going to lose all these entry-level jobs. They're going to be replaced by a computer that will take away all the typing and filling out of forms for us. But what we found out instead was it wasn't so much necessarily a threat to the entry-level jobs, but it allowed those employees to actually move up to higher level thinking. So what we did is, now that they didn't have to spend three weeks out of the month typing, we went through and figured out why, and put them after the task of how do we figure out why all these transactions were wrong and had to be corrected in the first place, and allow them to move up and become more knowledge workers. Another situation where I used that was in banking. We were actually dealing with filling out forms for international forms at a smaller bank that needed to deal with anti-money laundering regulations. When certain things happened, they had to fill out forms before they transfer money between different international locations. And it was just a huge overhead for them. One, to sit there and sift through records to realize when they had to fill out a form saying this is something over a certain threshold, under a certain threshold in terms of the amount of dollars. And then it took a lot of time to fill out the form. So the first thing we did is put in a tool to look into their systems and identify when a transaction was over a certain amount. But then they found themselves having to rush to fill out the forms all day. Well, we use robotic process automation to log in, basically like a macro, if anybody's familiar with that term. It would log in through the front end of the form, look up the information about the customer and the transaction from two different systems, and fill out the form and submit it to the authority so that their transaction would go through. And then the employees could spend their time focusing on helping the customers as opposed to just filling out forms all day. So really, if you think about it, RPA kind of becomes almost critical as you get into the larger volumes of data, as you start doing things like IoT, Internet of Things. You're generating all these transactions, but then when something happens, how do we deal with that, right? And that's where robotic process automation is really an outgrowth of trying to make it easier for people to deal with these large volumes of data that we created. And then everybody's favorite topic, artificial intelligence. Now, I'm not going to. There's so many layers to artificial intelligence, and keeping this to a business discussion, I'm going to tackle a few of them from the perspective of how do they affect those of us from a business point of view. Now, some of you may be entrepreneurs in the technology space, so you might be familiar with terms like neural networks and deep learning versus machine learning and fuzzy logic and things like that. If you're in that area, I'm not going to try to dive into that for the broader audience. But if somebody would like to dig into some of the details of that, I'm always happy to chat with anybody after the session. But really, AI is, okay, now we've got all this data. This is a form that needs to be filled out. We've got our RPA, which has gone out and helped companies, large or small, deal with all those volumes of data and keep up with what's going on, freeing up our users. But then how do we actually analyze and take action with all this data that's flying around out there? If you think in terms of those smart meters, so we had in our first trial, we had 80,000 smart meters, electrical meters on the side of the house. And we were reading them every 6 seconds. Well, at the end of the day, no human can, or a group of humans can effectively in time read through 80,000 machines providing data every 6 seconds. And you can only imagine, and that was in a small area in Oklahoma, you can only imagine how much data we were generating with Con Edison in New York. So how do you deal with that? Well, you use artificial intelligence, which is the idea of having computers make human-like, and the key being like, decisions by kind of sort of mimicking the way people think about things. So we're going to look just at a high level at a couple different areas. One is what we call general AI, and that's human-like intelligence. That's what you see on TV shows, science fiction movies. Always sounds interesting. You know, you're interacting with a computer, and this is where, you know, if you listen to somebody like the CEO of SpaceX and Tesla, Elon Musk, he's very fearful. He says that as general AI comes around, that computers will be able to think for themselves and they won't need us anymore, and humans will almost be an afterthought. Well, you know, that's kind of an interesting topic, but if you listen to the longer discussions of him and others, general AI doesn't truly exist at this point. It's something that researchers are looking at mostly to make decisions in medicine and things like that, where there's a large number of data points and there's a lot of feeling involved. We really don't have anything really approaching general AI right now. What we do have is a couple different areas that I'll talk about that are more impactful from a business point of view, that actually do exist at this point, which one is an inference engine, also known as complex events processing. It's how do you deal with what they call streams of data? What does streams of data mean? So that's like your IoT devices. So when that assembly line is running along and there's a machine on there counting every single item that we make as it falls into a bin for packaging and counting it, that would be a stream of data. You know, every 1 second that a new widget, as we say, is kicked off the assembly line, that device is counting them and sending them to us. Some of them pass QA checks, some of them fail QA checks, some of them clog up the machines. All things that you're finding information on. Some of the machines, like we talked about, are heating up or slowing down. All of those things are streams of data, things that are happening, going by so fast that we don't have a chance to for a human to look at them. And that's where we use what we call an inference engine to look at those things for us. So in the power grid, we can do neater analytical stuff after the fact to say when is the most power being used, but we can also do guided reasoning where we put in human implemented rules to guide the machines while they're going on. So for example, when we were working in New York City, we realized that once we reached certain thresholds, we could look if we had too much over here and not enough over there, but not enough power being generated over here, and too much power being used over there, and it was starting to get really hot over here. Then the computer would have a rule that when it's starting to get hot, well, we can probably figure out that people are going to start turning on those air conditioners too. Suddenly it's going to even be more power. We're going to run out of power. Therefore, I should go turn on those backup generators. So we turn the power on before people lose the power, as opposed to letting people lose their power and disrupt business and disrupt life and lose our power. So that would be an inference engine. Machine learning is the area where the system is developing new information or knowledge from existing data. So that would be where maybe we don't tell the system, we create a system that says to look for things that could impact rules, but we don't really tell the system what those things might be. So that's where the system might figure out on its own that, hey, every time it gets hot over here, the power grid goes down. Every time I turn on an additional generator, the power grid comes back up. So when I see it getting hot over here, the computer will go ahead and turn on the extra generator so I can get ahead of that situation. That would be machine learning. A more simplistic version of very simplistic guided machine learning is when you're shopping on Amazon, right? So you go on Amazon, I buy some tools for working on cars. I buy a book about cars, and it does something called clustering. It says, wow, what do other people who buy those things in that order next buy? They buy pictures of cars or something like that. So it goes ahead and starts prompting me when you see on those online shopping, whether it's Amazon or Alibaba or any of them that are out there now, even the app stores for Google and for Apple, they're always suggesting things to you. Well, that's basic machine learning. What it's doing is saying, what do other people They're doing clustering you, they say. It's basically they're profiling you. They're looking at what people that they decide are like you do. So based on, they kind of try to figure out how old you are, whether you provided that information or not. They try to decide if you have a family. They decide if you have a business because you're buying business items. And then they suggest things that you would like to buy. And if you think about it, a lot of even online startups, that's a really useful tool. And a lot of those algorithms are available fairly freely now. So if you're trying to figure out a way, selling things online to reach your customers and suggest opportunities of things that they might want that you would like to sell them, well, those little algorithms are basically a very basic version of machine learning. There's a couple different ways you can teach machines. You can provide them examples of things to do. This is right, that is wrong, or you can let them learn on their own. We'll talk about that a little bit as we get into security and some of the pitfalls that you run into. But that's machine learning. And those are really the two, probably the most popular areas of artificial intelligence right now. So to give a couple quick examples, there's some popular examples. If anybody followed IBM with their Watson tools, one of the things they were doing was in medicine, looking through at how do you deal with cancer, and they started realizing that's where they got into the area of general AI, that computers can help a doctor find symptoms and find treatments that work well to treat somebody, but they can't reason well enough to cure cancer yet. We still need doctors to guide them. Here's some more basic examples. This is this is data coming from that same machine I was showing you out there before. This is a system that actually I helped build, and now this is the data that was coming off those little boxes we were looking off of, that we were looking at on a day-to-day basis on our phone. And we were looking at trends of where the machines were running, where you see the nice peaks going, and where they stopped. And basically, this is another one of those situations where through machine learning, we were able to infer what the problems were and get in touch with people on the well site and say, hey, here's what's happening. You're running 3 different chemicals and they're all stepping on top of each other. We realized when you run those 3 together, you cause problems, then we drop off again. So we need to adjust the dosing of the chemicals, and then we can save everybody money. The interesting thing was that all the tools and the machine learning tools that we developed out here outside of development time, from an investment standpoint, we probably invested about $5,000 in being able to save millions of dollars for Exxon, which was able to get that company a nice little business. From the chemistry side, because they could do things that the larger companies could do, again, with only a $5,000 US investment. Another kind of AI that's, an example of machine learning taken to the ultimate level, that's a Tesla self-driving car. Basically, they're using what they call neural networks, which are, again, kind of a little beyond the context of this, but basically think of it as stacks of machine learning. So you have a group of machine learning rules that say, hey, when I see a car that I've identified using cameras in front of me, or I see a pedestrian in front of me, then I need to do something. And then there's another machine learning in there going, how do I react to a car in front of me versus how do I react to somebody walking in front of me? How do I react to somebody, maybe the person's trying to change lanes, driving it themselves, and the cameras in the car see a double yellow line, which in the US and some parts of the world means you have to stay in your lane, you can't pass, and they try to pass. Should I do something? Do I straighten up the steering wheel? Do I shake the steering wheel a little bit to let them know that they're going to potentially run head on into somebody by crossing? That's just a form of machine learning. And they have to take guided rules, and a lot of time is spent on those systems driving around. And the system is watching, if you were, going through and saying, okay, I'm watching this with my camera. When does the human being brake? And it adds that to a rule set and decides, is that a rule I need to follow? If the car in front of me's brake lights come on, I see more light coming off the brake lights. The human pushes the brakes. So now the computer learns that I need to push the brakes. So that's kind of the neat higher end stuff that the big companies are doing. But at the same time, for $5,000, a very small company in the middle of the US was able to come up with a version of machine learning that was able to get them customers like Exxon. So it's kind of neat, I think the expanse of where you can apply that from very small problems to very large problems. So then I'll talk a little bit about the supporting technologies, and kind of was giving myself a lead in there, is that, a few years ago, just like in the case of the agricultural side, having to go out and buy these large soil monitoring and sifting systems, or in the case of, you know, a large bank would have a really well-run server room, but a small bank would have a couple of computers in a side room that maybe weren't very well managed, but, you know, you just try to keep your data safe in there. If you wanted to do any of this kind of stuff 10, 20 years ago, and I'm old enough to have dealt with a couple of these transitions, well, what you needed to get was a large data center, a big secure room. You have security people, you'd have systems, because we didn't have Nest thermostats to manage the heat, the temperature, the humidity, and you get very expensive computers. You'd have expensive proprietary software from the Oracles and the SAPs of the world, those guys who charge millions of dollars to store your data. I worked for Oracle. It's a great business, but a lot of their higher end tools are really only accessible not to those of us on the startup side, but really only to people in the largest enterprises. And that was the only way that you could access these technologies. So when I was early on we were building some rules engines. I was with a company called WellLogix that dealt with helping companies like BP and Shell manage drilling wells and looking at different geologies and things like this. We had to go out and buy, you know, very expensive Oracle databases, very expensive Sun computers. We deal with people like Cray supercomputers. It was very expensive amount of entry to do that. And then we'd had to buy $1 million tools from SAS Institute, from Blaze Neuron Data Rules Engines. And really that's, you know, our customer base could only be the large corporations at that point. And the only people who had the money to invest into those kind of technologies. So they had a competitive advantage over those of us in the small company side, and they kind of kept the new entrants out. Well, that's kind of changed over time. So we've got a convergence of new technologies that have come together that provides kind of a democratization of access to these capabilities, by which I mean, you know, you can have a fairly small company now that can in some places compete with very, very large companies. And why is that? Well, people talk about cloud computing. So what is cloud computing? Well, I mean, everybody knows that your data is being stored somewhere else. But, you know, as a business owner, you think about it, okay, you know, when people were first industrializing the world, if you wanted to run machines, you'd have to go out and get very large generators. And sometimes we still keep our own generators. You're in an area where you don't trust the power. There's still brownouts. You're in the area where you need to have a backup. You're in a critical industry like healthcare, or even a factory where you can't accept that downtime. You have to have generators. But a long time ago, similarly to needing generators, if you wanted to run computers, the more and more power you needed, you had to get into massive amount of generators. And if you wanted to do a lot of computing or artificial intelligence type work, you need massive millions and millions of dollars worth of computers. Well, on the power grid side, what did we do? Well, utility companies started up and they had massive generation capability, and you just bought a little bit of power that you needed for your factory, and maybe you backed it up with a small generator if you needed to, but you didn't need to own your own power plant in order to have access to that level of power to run a factory or run a small office. Well, the cloud is basically the same thing for computing. Microsoft Azure, Google Cloud, the Amazon Elastic Computing Network are simply that. Think of it as in addition to a place to store your data, it's like a power plant for computing power. So you don't need a whole power plant to run a very small factory. Well, you might want to run a machine learning model, and it'd be extremely expensive to buy a computer big enough to run it, but you don't need to have it running all the time. You just need to analyze things here and there. Well, you only pay for what you need. So you can run that on their architecture, and you can have the ability to do that without spending that kind of money. Just like you don't need to build a power plant, you don't need to buy a supercomputer anymore. You can just borrow a little bit of time on somebody else's and have the ability to run really fast machine learning models, just like the big companies do. And then the other piece of that is the open source software model, which, you know, again, back in the day, it was talking about those Neuron data, the Oracle databases and things like that. Now, like from the IoT side, there's IoT centric databases that, you know, you could put up in minutes that would allow you to capture data from a machine on an assembly line in a very small factory. It would allow you to take the data from one of those sensors that you put out there in the soil in an agricultural environment, and they cost exactly nothing. There's you can buy up into greater levels of support, but you can get a database that's optimized for taking thousands and thousands of millions of transactions from those soil sensors or from water sensors and things like that for free. And then you can run it on your own computer, or you can run it on the cloud. And those capabilities like that, machine learning with a tool called TensorFlow, if anybody's familiar with that, from Google, the entry point into all those, if you're a startup, is free. So now you have access to those kind of tools that previously only the largest companies would have access to. Just trying to keep up with my time on the side here. And now that gives an opportunity that maybe entrepreneurial companies can move as fast or even faster than their incumbents that have the legacy infrastructure. And then the last piece I'll talk about, and that's where I'll kind of wrap up and then move over and let everybody ask some questions, is security. So why is security so important? Well, obviously we need to protect our data. We need to make sure people don't steal our financial data. Maybe we've invented a new machine. Maybe we've got some new customer lists of new customers we've been able to access and who we know over there. And we don't want some hacker to break in and steal that information. But the other piece of that is just important, is to protect our reputation and to keep our customers' trust. So large retail store in the US, Target, lost a lot of their top executives because their customer systems were hacked, and all of a sudden anybody who'd used a credit card at Target had a pretty good chance that somebody had stolen their credit card. Well, Target, fortunately for them, had billions of dollars, so they could hire people to clean up their reputation and reach out to people on that. If you're a small company and you have your first couple hundred customers and you put up a website and somebody steals the information on your first couple hundred customers, they may not come back. So security becomes more important. The new technologies can help protect us. That's the other piece of this. Back in the day, you probably get pop-ups on your computer quite a bit about it's time to update. Well, if you're running a server on the internet for a simple shopping site, you need to really keep up with those. Amazon, Google, and Microsoft, when you're on the cloud, they take care of all that for you. They monitor it for you. They secure it for you. They can use AI tools, and those AI tools can help proactively detect those threats. And IoT, you can use that, video doorbells, video cameras to protect your facilities, to see if there's a problem, to see if there's a fire, to watch your assets when you're not there. However, they can open up new vulnerabilities. There was an issue with smart thermostats. Like I said, people were putting those into very, very small little computer storage rooms. Well, there was a popular thermostat tool out of Europe, and somehow or another somebody figured out how to hack them, was having fun making people uncomfortable by turning their heat up or making their air conditioning too cold. But then people were playing around the internet looking for those thermostats and turning them up. And then all of a sudden, if you're using that to keep your computers cool, and somebody started playing with that, all of a sudden now somebody can turn up the heat and maybe destroy all your computers, right? And overheat them. Somebody came up, big ships now have what they call automatic identification systems on them so that we can track them. Well, people came up with the idea that wouldn't it be neat if we could allow small boats to have those? So if you're coming in and out of a large port and you're on your sailboat or your small power boat or a fishing boat, you know where the large ships are so you don't run into them, basically for traffic control, just like you would have in an airport. They do that for ships now. However, there was a Dutch man went to Indonesia, and he took a simple AIS system, and he started tracking ships. And then he took another system. He was doing his own robotic process automation, and he was looking at another system that was to track what was on ships so you could track your shipments. And he was dealing with people in piracy and basically using the cargo tracking to figure out which ships had expensive things on it, and then using an AIS system that was designed for fishing boats to stay out of the way of large ships and helping target ships for piracy. Other things you can look at that are maybe not security, they could be accidents, or they could be true, is bias or just errors in that unsupervised machine learning. We talked about there was a Microsoft chatbot that went online, and like I said, people started telling it dirty jokes right away. It was designed to look like a general AI where people could chat with it. It would learn just from everybody on the internet chatting with it. Well, a lot of young kids started chatting with it and saying bad things to it, and all of a sudden it started replying to everybody that chatted with inappropriate terminology, and Microsoft was so embarrassed they had to take it down after 4 days. Example of unsupervised machine learning. Another example actually that was interesting, since you have those clusters online, Amazon and other companies like that start deciding what they're going to buy based on what people have been buying in the past and group behavior. Well, I was reading an article. I got a note here to the side. It was I think it was in the last issue of MIT Technology Review, that when COVID-19 hit, all of Amazon's models, well, a lot of them went around the mainstays, the top 10s, phone cases, phone chargers, Lego blocks were the most popular things to buy in Europe. And then they weren't seeing that in certain parts of the world, starting in Asia and moving to Spain and up to France and over to Canada and the US, that the things that were being bought were hand sanitizers, and their models couldn't adapt fast enough, and they got caught short on things like hand sanitizers, face masks, and things like that, because their system said we will always overweight the most popular items from last month this month. So they were still buying lots of phone chargers and lots of phone cases and things like that, because that's what people buy the most. And again, they're starting to realize from that is that they need to start tracking what's going on in the world and tune their models a little bit when they're deciding what to buy, to start looking at different parts of the world for trends like that. That, you know, in this case, we had a unfortunate pandemic coming on. And if their models had been maybe a little bit better, or people had been interacting with them a little bit more, they probably would have been a lot more hand sanitizers and face masks available on the front end of these things. So anyway, again, just an example, not necessarily of security, but kind of the impact of either bias or allowing, in the case of Microsoft, just schoolboys to drive the teaching of their chatbot. So obviously, kind of a brief overview. I hope that wasn't too technical or too broad I hope that wasn't too technical for the people coming from the business side, or too broad for people coming from the technical side. But I just want to give a brief overview of the kinds of things that you might see. And obviously, there's lots more to learn from there on how to apply these things. But I hope that gives everybody a good example of, you know, there's a lot of neat technologies out there. And really, I think the most important thing is any of us can use these things. If you're not using them now, they're far more attainable and far more applicable to your business now, whether it's you know, RPA is really revolutionized in a lot of places, small call centers. IoT is really revolutionizing farming and small to mid-size manufacturing. AI is making huge strides in retail, medical, and education. So these are really things that all of us can take advantage of. And with that, I'll try to open it up to questions.
Thanks a lot for this great. It's opened a window for expose the importance of technology, how important it is. Khalid Sahib, you'll have to wait. You can only write. So Asim has asked a question that. Okay, so anybody who wants to ask a question, please write here. And
Okay, I think Mr. Robert, you will need to enable the chat again so that the participants can write their questions down.
Okay, let's see. So it says now that attendees can chat with everyone now. It says.
All right, perfect.
So can everybody mute? Khalid साहब आपको रिक्वेस्ट की गई है कि आप म्यूट कर दें. ये इसका एक तरीका होता है. आप पहले चैट लिखेंगे, फिर आपको मौका दिया जाएगा. Please.
And Robert, also, if you can just pass the hostship over, so I can control the people.
Yeah, if you can pass the host to Taskeen, I'll appreciate.
Okay, let me see if I can figure out how to do that. Let's see.
Yeah. Just go to right on the part, find a participant, write Taskeen, T-A-S-K-E-E-N, and her name will pop up. Her name will pop up.
And make host. There we go.
Yes, exactly. Thanks a lot. So Taskeen, can you read? I can read the question. That is Madiha. She's our woman participant. The question is, there is very less literature available about women technology entrepreneurs. In your point of view, why women are reluctant to engage in high-tech entrepreneurship?
Well, that's, you know, I've always wondered that myself. If you look back to the history of technology, you know, Admiral Hopper in the US, if anybody's familiar with one of the first popular businessing programming languages was COBOL, and it was invented by a woman. And the term computer bug actually was created by a woman, same woman, because on the early computers, they were giant, and she actually had a moth land in the computer and short it out. And that's so computer bug was literally a bug when it first started. But anyway, that was a woman who started that. I think that's changing a bit now. For some reason, it's mostly, I'll say, in the American kind of Silicon Valley side, it was sort of a rock star, frat boy type of mentality. Was exciting, fast cars, rock music, kind of flashy, kind of a tool. In the 2000s. I think there's a little bit of a carryover from that during the sort of the excesses of the dot-com days where people got pretty excited about that. And there's still a few areas where people think about women not being in terms of, from engineering, kind of the high-end sort of back office engineering, creating the custom algorithms. For some reason, there were a lot of men in that. However, though, if you look at things like mathematics, which is really, women were more represented in mathematics in some places than men. And if you look at machine learning, it's more math than it is computer science almost. So that's seen a very big influx of women into that. If you look at things like robotic process automation and you go to companies in that space, you're seeing many more women involved because of areas like healthcare, education, call centers have a very high representation of women in there. And a lot of times they understand the business cases for where you need to apply these much more than sometimes men do. So it's giving again an opportunity for them to come in and participate because they have just a huge amount of knowledge to bring to the table.
So one of my friend is asking from Islamabad that RPA has resulted in layoffs of outsourcing companies because of automation. Taking as data entry and medical transcription. How can entrepreneurs use these technologies to launch new business in developing countries? Any idea?
Yeah, no, that's a great question, actually. One of the things I found is that you, again, kind of like my Ally Signal example, where people were able to repurpose to higher end tasks. The neat thing about better RPA is, so I did some work where we were dealing with basically medical data entry again with people, and originally there was large groups of people entering in data into each system. Well, what we found out with is that we could start servicing large customers and more customers on a faster basis using RPA because it gave an ability to interact with 4 or 5 different systems in the past. So there were certain kinds of data entry that companies had been taking back internally because they had to use if you're familiar with those companies, the TIBCOs, the web methods to do integration on the computer side. So they started taking that over and taking it away from the outsourcing companies and doing it on their own. RPA started letting people do the integration from the front end, and that opened up the ability for startup companies to start pushing back. And I have several friends that are actually in the RPA space that work for RPA companies or are implementing RPA technology. And that is one thing that they found is now it's opening up the opportunity to enter back in from a different angle in areas where customers needed integration, but couldn't really afford to do the back-end integration. Sometimes the service providers, by becoming RPA experts, were able to do it much cheaper than the companies could internally, trying to tie their systems together without people being involved on the front end.
So Robert, here's my question. Because outsourcing companies are now getting rid of the old jobs like data entry and medical transcription, in which technologies should they be training their employees so that they can meet the new requirements of their foreign clients? Like, what are the areas where work is being outsourced? What are the technology areas where companies in USA and Europe are outsourcing IT work to countries like India, Pakistan, Philippines? Where do you see the opportunity for outsourcing?
So I think more of it's going to move to, so it's going to trend a lot. So one area that's actually fairly interesting that I've seen is a lot more accounting. And by accounting, I mean tasks now can be accessible. Before it was just data entry, like you said, typing in invoices. And then somebody in the corporate back in, say, the US is in there making decisions about, okay, now that the invoices are all entered, all the ones above this amount have to go into this bucket, all the ones above that amount have to go into another bucket, all the ones that are in these areas. Companies that are embracing RPA are finding out that they're able to outsource much higher level tasks remotely that were traditionally done in-house. So I would say, a combination of RPA, some of the machine learning, because that's where RPA gets interesting, is when you start tying in some of the AI concepts. you can provide a lot more value. And then of course, always compliance around AI. But if you can make a good case that you can more securely and safely do front-end integration through tying multiple systems together through forms, people are going to be pretty quick to outsource that, because it's just so much cheaper than the way they've been doing it in the past, doing the back-end integration system to system.
Thank you, Robert. There are some MBA students in our session, some managers, and Mr. Shuja has asked a question that what are the new competencies that you see in the management leadership? So what should the MBA students shall look for? What should they prepare for? Traditionally, we don't teach these courses. We teach HR, marketing, finance, operations, very less about data analytics and data mining things. Your suggestion?
Exactly. Well, I think the big thing is in the courses here, and this has been something I've been thinking for a long time, is there was always a tough little bit of a chasm between we taught the business side and then we taught computer programming, right? And then when I got out with a business degree and started getting into technology companies initially, even before I got into oil and gas, one of the things I found out is none of the technology students understood anything about the flow of business. They didn't know anything about accounting. And, somebody would tell me, okay, we have a problem with payroll and we needed to fix the payroll system. And I'm like, well, how do I find, who's telling me this? Accounting. And well, accounting then talks to payroll, and then payroll talks to benefits, and benefits talks to treasury to figure out how the money gets there in the first place. And the problem was in a completely different place than I understood. And then I realized that the people who had gone through then I understood that business people didn't have any understanding of what the technology was. So I think that's a great question, that there's going to need to be more, a lot more coursework and a lot more case study type work done around how to use technology to solve business problems, right? Like, what if, the things we were doing from an oil and gas side, people thought it was unbelievable that a little company as tiny as my customer could solve these problems. Well, it was just us getting together people who understood the engineering and the business, and overlaying them with people who understood what was capable from the technology side. So really, it's exposing business people to this kind of level of discussion about how do you apply technologies, what's available, what can be done. Because you haven't worked in that area, you would never think that, for example, machines could make decisions about turning things on and off on the power grid. And that wasn't that hard of a project, but nobody had ever thought about it before, because people coming in from that side hadn't really thought about computers making their own decisions on the fly. And then people who were doing machine learning they were doing things like gene sequencing and never really thought about it to use to control the power grid. So it's just getting those two sides together, sort of the left brain, right brain, if they'll say.
So I would like to have comments from Kevin or Hans from Bangkok, if any. So you can please jump in. And then many people are asking one common question about the post-COVID. So we can take comments from Kevin and Hans, and then we can come to this question. What do you think about the post-COVID opportunities? Yes, Hans from Bangkok. You would like to say anything?
Well, Sawadee krap. Hello, good evening.
Good evening.
To me, a more technical question. If we look at sensors and the companies producing sensors, they put logic into the sensors, and I assume because software has no value, so they produce embedded systems to make their products valuable and unique. But this implies that to organize this in a factory production, I have to deal with a lot of proprietary systems and interfaces, which makes it all to an expert system. So what I think the future should be from the educational part, that we understand that the sensors are just idiots giving I/O data into the IoT, and then the logic is in the IoT. Because when I have my hand here, when I do this is just not done by my head, but when I raise my arm, this is done here. So I don't need logic here. So what I think is that the technology companies, and that's my question, are the technology companies producing all the important sensors to get inputs and outputs? Are they just the country to the future fast development of IoT?
Oh, that's an excellent. Wow, that was really good. It's almost like you're prompting me with questions. I appreciate that. So no, absolutely. So in our example, just our example out there in the oil field, in reality, there was about 70 sensors from about 30 different providers out there, which I didn't want to go into the detail of, but that's an excellent point. So each one of those was producing a sensor thinking that was their value. But really, we found the value was pulling them all together. So I worked for some of the large integration companies in the past. Oracle had an integration practice. I worked with TIBCO, probably the information bus company does, integrates, everything from stock exchange trading floors to things else. But they sell really expensive tools. But there's some neat tools. Again, open source. There's a tool called Node-RED. You can download it yourself, play with it, anybody. And it's great for pulling in sensor data. And again, it's a free tool. It's an open source tool. And, it's got a palette of about 75 different ways that different sensors and different tools might talk. It can talk over, IP, like an internet device. They can talk over Modbus, which is a machine device. They can talk over RS-485, which is different Modbus, serial communications, network communications. And really now I realize it's one of the neat things is the market's starting to come together to deal with the problem that you're talking about and making that more democratized, which is how do we get the sensors, all those different sensors together. And what it allows you to do is create a web to reach out to those different sensors. So what we did in that case, to go a little bit more of the details, we used that free tool and we talked to these 70 sensors from 30 different vendors by probably 25 different protocols. And it made it fairly easy for us to do it. And then we put it into one format where we could see all the data. And then from the business machine learning and from the human side, we didn't care about what kind of sensor, that there was, 4 different sensors doing 4 different types of water property, or 2 different sensors doing pressure, or 5 different systems doing injection. At the end of the day, it was just information that we were dealing with. So yeah, that's actually one of the most exciting parts of all this, is being able to have tools that can talk to all that data and free the data that's coming out there so we can take action on it.
Thank you very much. Kevin, you want to say something?
Sure. I really appreciated your example from the guy on the boat connecting the 2 sets of data.
Oh, yes.
To create an actionable insight. And I think fundamentally, that's what this is all about. That's the power of AI, is if you can find data from one source. And for entrepreneurs, for everybody listening, this is just a different variation of connecting 2 different ideas and finding a new application or business, which is the issue, the essence of entrepreneurship. So if you can look in the world around you and see what are 2 different data sources that, if you connect them, can create unique and valuable insights. I think that's one of the biggest takeaways I'm walking away with from this presentation here. And I want to give an example or 2 to show it doesn't have to be difficult. There's a guy I met recently, and he wanted to get into the auto insurance business. And so he realized that Tesla cars generate data. Mm-hmm. And one of the most important things they do, it tells the data when the car owner is driving. And then there's another mode for when the onboard computer system is driving. Mm-hmm. So his business insight and the business that he has started is to sell car insurance by the mile. And there's a price per mile if the car owner is driving. And there's a different price per mile, which is 1/4 of the price if the computer is driving. And then there's a third price per mile for every hour that the car is just sitting there and nobody's driving, but maybe a tree or a school will hit it or something. And that's his proposition, is it's buy insurance by the minute, and you pay 3 different rates, whether the car is moving, not moving, and who's controlling it. And he has created a business by connecting 3 data sources from the onboard computer of Tesla, and he's now in the insurance business. And that, I want to use that example to show that entrepreneurship is about how you're going to connect different data streams to create a unique value. And I want to ask you to repeat the tool that you mentioned where we could play with data stream. And I also want to mention that the city of Boston is making a lot of data streams available to entrepreneurs in the city. So if anybody wants to take the tool that you recommended and take some data streams, the city of Boston has made a lot of data streams available for movement of people in the city.
Great.
Yeah, to allow entrepreneurs to experiment with connecting data. So that's what it's about, guys. It's about having the capability to the tool. Robert, please repeat those tools.
Oh, absolutely.
Play with the tools, play with a data set, and get used to putting together two data sets, and that's where the opportunity and the value will be created. I'm just oversimplifying here, but that's my takeaway. So
Absolutely.
What was the tool, Robert? The magic tool you used?
One of the ones for capturing the different data streams is a tool called Node-RED.
Node?
Node-RED. Node-RED.
Okay.
It's a little confusing to install at first, but fortunately there's about 1 million YouTube videos of how to install it, and it takes about 3 minutes. Okay. And then once you start playing with it and you start realizing you can do neat things that we used to, you know, as at Oracle, we'd have a team of 20 people do over a month. You can do in about 5 minutes. If there's a data stream out there, you can say, hey, there's a data stream at this address, take it and look for this kind of information in it and send it out to another message. And then you can take different actions. If you see a message that looks like this, then do this. If you see this, then look like that. It's a little bit of a, there you go. Thank you. And it's a little bit of a, it's a little techie at first, but once you get the handle of it, you can usually find that once you get the basics done, it's almost more of a tool for business people. There's some other neat pieces that go well with it. I've used a database called InfluxDB, another one that's available for free. It's great for pushing data to from your Node-RED and storing that data. And it's got in some built-in graphics tools. So that the graphics you saw out there on that Exxon well site, that was Node-RED and Influx database and their built-in dashboard. And we built that all in. Actually built it in the field because we were trying to find a way. We had a new entrepreneurial company that I was consulting with, and we were about a little 10-person company doing a couple million a year. And actually, because we were able to have those better insights, it became a bigger, about 70-person company with about a $30 million a year in revenue. Because they were able to go out there using a bunch of free tools and put that together in the field and provide more insight than the Halliburtons and the Schlumbergers and those large companies could, and able to gain some business for a startup that was a very small kind of family-run startup.
Fantastic.
Great.
And
there's a quick question.
I'm just posting the Boston data sets here.
Oh, great.
So that anyone can grab those data sets.
Oh, wow.
And if you want to take those data sets with the tools that Robert mentioned, you are now all empowered to be, potential AI. We need a term, AI-preneurs.
AI-preneurs. Yeah, there you go.
Robert, there's a quick question by a friend, Mubashir from Islamabad. He's saying that in addition to cloud computing, he says edge computing is also very important to a large extent. Absolutely. That's an excellent point. So edge computing, we were doing that actually in some of these cases. It works well with IoT. So when you go out, if you're in the middle of New York City and you have a bunch of little devices and you want to make decisions, you can send everything up to the cloud and do it from there, as long as you have a really fast data connection. When we were doing things out in those oil fields, for example, or out from an agricultural standpoint, you might have data connectivity, but it might come up and down. So what we did was we needed some edge computing. So in the past, we looked at what other people did. They would get a stack of servers and they put them in a machine like that. Then we realized, well, what if we got a Raspberry Pi, a computer we can buy for $30, and we installed some edge computing capability, which basically, another great term, edge computing means a question that you can ask or processing that you can do right on the edge, right where things are happening. And it works great in an IoT type example. If you need to learn some basic machine learning, you can run a very simple $30 computer like that, talk to a few sensors, and then decide if the data needs to go to the cloud, right? So if you find an exception, there's something interesting happens, there's some data that needs to be analyzed, then you send it up to the cloud. If you just need to do something like open a valve, shut a door, stop the assembly line, maybe no, that doesn't need to go to the cloud. You can use edge computing and make the decision right there. So that was a great question. There's a lot of questions and people are so interested actually. And they seem interested in this talk. We never had so many questions, Bina. And so I think we have taken a lot of your time. And the last question: that do you see any post-COVID things coming up, emerging out of AI and technology and new things coming up? And then yeah, we will be taking questions.
Yeah, absolutely. So, you know, as we look for solutions in a COVID world, AI is, in machine learning especially, has helped a lot in previous cases with dealing with medical issues. I think it'll be even more, just as important, or even more important as we go forward. You know, like I said, IBM made the pledge they were going to try to use AI to completely by itself cure cancer. I met with some of the people working on that. No, we still need doctors, but we make knowledge workers go faster by applying this kind of technology. Also, for the rest of us out there in the world, you know, I think you're going to see a greater access of all of these technologies. Like we said, how do you respond from a supply chain standpoint to issues with in times like disruption, like we talked about in the MIT review, both with Amazon, but also with small companies? How do you see trends like that happen? Machine learning can help you with that. IoT can help you with not having to travel as much. You can monitor things from afar when you're social distancing. You don't have to have your employees go in and check everything every now and then. If you have even a small automated assembly line, you can use AI and IoT together to monitor your assembly line without having to make all your workers come into the factory, and they can still do their jobs and they can still make decisions without exposing them to that. So I think as when tragedies like that happen, I think that you'll see that there'll be an acceleration of the adoption of some of these technologies now, just like we all are doing, just like Zoom has become so popular, even more so than before over the last couple of months.
So once again, I'm so overwhelmed, and thanks a lot to Robert for sparing his time. And I'm thankful to Bina Ulhaq, who has been so kind and partnered with us to help the Pakistani men and women learn and develop networks. My friend Amar Zahood is there. He started a call center, which was very growing, but suddenly, and he's looking for new opportunities. So I hope and wish him best of luck. And I wish many men and women who have benefited from Kevin and Hans a lot of good questions, which enabled us to learn more. So Bina, would you conclude? And thank you once again on behalf of IBA.
I would. Can I ask one question, please?
Yes. Yes.
It's a quick question, Robert. I know we know lots of cyber attacks on the routine basis in the industry we work for, and I've been informed. Actually, I've been texted now by someone that Pakistan Bank had a cyber attack some time back. So would you like to shed briefly some light how they can handle it? I know it's a deep topic and everything, but please briefly if you can shed some light.
Sure. Now we can set that up for a follow-up, but in general, one of the trends is AI is being used, machine learning. That's another area we didn't talk about too much, just very briefly touched on, to look for patterns of attacks. Right now, almost everybody's put in the firewalls and done things like that, and you know, see if somebody's taken over their computer. Right when somebody starts writing on the screen in a Zoom message, you know you're being hacked. But there's also lots of subtle clues that happen when you're being attacked. And machine learning has been excellent for connecting those dots before attack has completely taken place. You know, people trying to log in under different credentials, people trying to accelerate their credentials over in another place, weird pings and network traffic coming together are often signs of attack. And people usually are realizing they used to see those after the fact, and machine learning can actually intercept those ahead of time. So that's been a great way to deal, that people have found to deal with cyber attacks going in forward. And that's actually becoming almost a specialized part of AI, is dealing with cyber.
Perfect. Robert, thank you so very much. I must say great thank to you and Dr. Shahid for attending such a lovely series of different topics. And I would say thank you to Kevin, Hans, Professor Hans, everybody else who has been taking a great interest and participated in this event. I would also like to say thank you to Mr. Shahid's team, Talha, Abdullah and Taskeen. And thank you, Khaled, and everybody who's attended the session. Robert, I do understand you're very, very busy. I know your schedule, how it works around. It literally works around to 22 hours a day. So I really, really am thankful because it's your first visit to my home country. My roots belongs to Karachi, so I have a special spot. And you know this better than anybody. Since last 5, 6 years, 7 years, you know me. Every time you hear one thing, which is we have to do something in Pakistan, and I'm so happy today my dream come true. So I am really, really thankful to you and to Dr. Shahid, especially for.
Beginning, I think it's a great beginning.
So thank you, everybody.
Wish you best of luck and have a great day. We will pray for you tonight, as there is a spiritual night in Pakistan in Ramadan, and we'll pray for you and the whole world. Goodbye. Thanks a lot.
Thank you very much.
Take care. Thank you so much.